Alright, so now we're going to take a look at more how we can find the area, of course, using geometric formulas. The important thing to remember is when we look at that definite integral from a to b, f of x dx, all this does is it finds me the area under a curve. That's all its job is to do. So when I see an integral that says, an integral that says I want to find the area from 1 to 3 of my function. So I know right away all they want me to do here is to find the area. So I need a function. So we're basically saying find the area on the function f of x equals 4 on the domain 1 to 3. So I'm going to graph it. F of x equals 4 is a horizontal line at 4. I'm looking at the region between 1 and 3. So if I draw this out, I'm looking for this region, and I like to shade it. You should shade it. You can sing the Shady song. Slim Shady, yes, I'm the Slim Shady. Right? And I just want to find the area of the shaded region. Well, I know that the width here is just going to be 2. The length is going to be, of course, 4. So the area, this is just a rectangle, length times width, so the area is going to be 2 times 4, which is 8. And there's our answer right there. So we can say, therefore, you probably should write it this way. The area from 4 dx is 8, but if you forget that, that's okay. You just want to make sure you can get that area right there. So let's take a look at number 2. Again, I'm looking for the area, so we're looking for the area on the function f of x equals x plus 2. Notice this is a line on the domain 1 to 3. So I'm going to sketch it. I want to see it. X equals 2. It doesn't have to be perfect. There it is. There's 2. It's a positive slope for a line. It goes up. And I'm looking for the region between 1 and 3. So I am looking at this region right here. Alright, so we have to think about, well, what formula is this? Well, it is a trapezoid. So what is the area formula for a trapezoid? Right, it's going to be the 1/2 base 1 plus base 2 times the height. We're going to have to know this later on, by the way. So to get my area, well, the hard part I think most people have trouble with is what are the bases going to be? Well, the bases are the ones that are parallel to each other. Very funny joke about parallel lines. Here it is, the funniest joke you'll ever hear in mathematics. Imagine you find yourself at a math conference, and they're pretty boring. All you got to do is stand up and say, hey, 2 parallel lines meet on a plane. Get it? They're parallel lines. They don't meet on a plane. Funniest math joke ever. Alright, so base 1, I got to find the height here. So that's easy to find. I just plug that 1 into my function. That's just going to be 3. To get base 2, I plug the 3 into my function, and that's 5. So I'm going to get 3 plus 5 for the sum of my bases. Now the height, that's this part down here, which is going to be 2. So of course, if we simplify that, we're going to get 8. The area is just 8. Okay. I promise you not all the answers are 8. Okay, 3 and 4. Listen carefully. For number 3, we can't integrate this one. Now you might be thinking, Mr. Warner, what are you talking about? There is no possible way to integrate this. Okay? We don't integrate this ever. So we recognize the shape. Sometimes we recognize the shape. This is a semicircle. Okay? We're saying f of x equals the square root of 4 minus x squared. This is the top of a circle. It is the top of a circle because you really have plus or minus. But since this is positive, we're looking at the top. If it was a negative, we would be looking at the bottom half of a circle. So this is a top of a circle with a radius of 2. Now, where does that come from? Our equation, x squared plus y squared equals in this case 4. If you solve for y, you would get the square root of 4 minus x squared. So we always graph circles. We always, write this down, always graph circles. Okay? No matter what. You can be tempted to do other things, but just graph it. This is radius 2, negative 2, and I go up. It's only the top half, so I want the area of the circle. So the area, 1/2 pi r squared, the area of a circle. So the area here is going to be 1/2 pi. The radius is 2 squared, we get 4, so we get 2 pi. And there's our area right there. Please always graph circles and absolute value. We've done this before. This is absolute value, and it can be chaos if you try not to graph these. So we, again, always sketch, always graph these. You like graphing absolute value. So if I were to graph this one, this has a horizontal shift at 1, and it goes up like a gigantic check mark right there. Now we're looking at the domain from -1 all the way to 4. So I'm looking at these areas. So I'm going to drop my lines right here, and I'm looking at these areas. Now notice I have 2 areas that I have to worry about here. Remember what we said, so we can split an area? Remember our notes, right? We can split an area. And that's what we're doing here. We have 2 areas, and they are both triangles. So the first one, I got to find its height, of course. That's not too hard to do. Plug -1 in. -1 minus 1 is -2, but the absolute value is 2. Plug the 4 in. Okay. 4 minus 1 is 3, so there's our height here. And I'm just going to find the area of those 2 triangles. Area equals 1/2. Well, the base of the first triangle is 2. The height is 2 plus 1/2. The base of our second triangle is 3. Its height is 3. So we would get area equals, this is just 2 plus 9/2. I don't know what that is. I just leave it alone. I'm just teasing. That's just 13 over 2 if you want to simplify it. Always graph circles and absolute value. And that brings us to our last example. I know, long notes today. All right, number 5. We want to find the area between -4 and 4. And they give us 2 lines. And this is actually, by the way, a semicircle. Remember, we always measure to the x-axis. Write this down. Measure area to the x-axis. Because, again, if we are below the x-axis, it's negative area. It's kind of like slope. We're going to talk about that later on. Positive area above. So that's where we always measure to the x-axis. Remember, it's like slope. If this is the graph of my derivative, remember, that's a derivative function, right? Remember, if it's inside the integral, that is a derivative. Recall, f of x is a derivative. So anything below, negative. Anything above, positive. Same is true for slope. Same is true for area. Isn't that kind of cool for us? All right. So notice, though, if I do that, I have these little breaking points right here. So I'm going to have actually 3 areas. This triangle, this circle, and this triangle. So, again, very important, positive area, we are if above the x-axis. Negative area if below the x-axis. So that's what we're looking at right here, okay? So let's go and get those areas. I'm going to call this area 1, area 2, and that one area 3. So when I want to find the area for 1, it's a triangle, 1/2, the base, 1, 2, 3. The height, let's be 2. Now notice, I do make the height positive, but where I put my negative is out here. Now you can make this a -2 if you want, but I'm going to put the negative out here. Okay? And that is because we are below the x-axis. So that's going to give me an area of -3. So the area here is -3. We're not saying the area is actually negative. That negative means something for us. For example, in physics, we talked earlier about work. You can have negative work. Some of you guys have negative work in my class. Area 2, This is a circle, and it's above the x-axis. It's a semicircle, 1/2 pi. The radius is 1 squared, so we just get half a pi. And area 3, again, it is a triangle, but we're below, so I'm going to write the 1/2. The base, count 1, 2, 3. The height, 2. But again, we're going to make it what? Negative, again, because we are where? Below the x-axis. And again, that's going to give me a negative 3. And then to get the total area, we're going to add them. Negative 3 plus pi over 2 plus negative 3, or negative 6 plus pi over 2 in this area. Very easy to do. All right, hope you guys enjoyed the videos. I'll see you guys later. Bye-bye.